Hello, we're going to go through 6.4 rational exponents today. Simplifying expressions with rational exponents. We're going to start with a couple different ways. If we have a number to a certain power, some different options we have to simplify it down. So the first one is 216 to the 1/3 power. Notice it's in exponential form, so we could switch it to radical form. We've been working with radicals. We might be more comfortable working on it in radical form. So how we do that, this 216 is going to go underneath our radical. The denominator goes as our root, and the numerator goes as our exponent. So we'd have the cube root of 216 to the first power. And then we could go ahead and simplify it just how we have been. 216 to the first power is just 216. Do our factor tree for 216. It's 6 times 6 times 6. Then we're going to put them in groups of 3. So we have 3 6s, so we can bring out a 6. So then our final answer is 6. Another way that we can do it, if you're wanting to try to do it on your calculator, that 216 to the 1/3 power. So do 216, do the caret button. And the caret button is this just arrow up button right above the divide by sign. So caret, and then I'm going to put 1/3 in parentheses. So parentheses 1 divided by 3, parentheses, and then click enter. So it knows that that's all in the exponent spot, and we get 6 that way. Number 2, we have 7 to the 1/2 power times 7 to the 1/2 power. So a couple different ways that you can think about this problem. If we want to work on it in exponents, then notice how the bases are the same. So when the bases are the same, we go ahead and add our exponents. And we can only do that if the bases are the same. So the bases are the same, we keep that as 7, and then add our exponents. 1/2 plus 1/2, which we end up getting 1, so 7 to the first power is 7. Another way that we can do this, we can switch it to radical form. So 7 to the 1/2 would be 7. We're going to put underneath. The denominator goes as our root, and the exponent, or the 1, the numerator goes as the exponent. And then this one, 7 to the 1/2 again. So the 2 goes, and the numerator goes as a root. The 1 goes as the exponent. So we have square root of 7 times square root of 7. That would just be the square root of 49. Square root of 49 is just 7. So we could do it that way. This next one, we have 5 to the 1/4 times 125 to the 1/4 power. So this one, notice how up here we went ahead and the bases were the same, so we just added our exponents. Well, we can't do that right from the start just because our bases are not the same. But if you liked that method, another option that you would have, think about 125 as 5 times 5 times 5. So we could rewrite that as 5 to the 3rd power. Well, now, when we have a power to a power, the rule is to multiply those. So 3 times a 4th, we get 3/4. So we have 5 to the 4th power times 5 to the 3/4 power. Our bases are now the same. So now we could go ahead and leave the base alone, and then we would add our exponents. So 1/4 plus 3/4, we'd get 5 to the 1st power, which is 5. Now if you liked this second option, we could do that second option, that the 5 would go underneath the radical, the 4, our denominator, would go as our root, and our 1, our numerator, goes as our exponent. This one we'd have 125 to the 1st power, and then the 4th root of that. And then we go ahead and 4th root of 5 and the 4th root of 125, they're both 4th roots, so we can multiply them. So we have 1 5 here. 125 is 3 more 5s. And when we bring them out in 4s, or groups of 4s, so we have 4 5s, so then we get 5 that way. This next one, we have 64 to the 1/2 power. So we can go ahead and put 64 to the 1st power, and then the root is 2. So the square root of 64, and then 64 is 8 times 8. We have a pair of them, so we can bring out an 8, so we get 8. Another option that you can do for this one, that we could, if you liked this top option, we could do our factor tree for 64. We would have 2 to the 6th power is 64. and then that's to the 1/2 power. And then from here, power to power, we multiply those. So we have 6 times 1/2 is 3, 2 to the 3rd power, we could get 8. So that would be another option that you could do. Now we're going to add in the variables. So converting exponential and radical form, we have 7 to the 3/7 power. So again, the denominator goes as our root, the numerator goes as our exponent. So we have the 7th root of x to the 3rd power. We have 3 x's underneath if we think of that in an expanded form. We don't have any groups of 7, so we can't bring anything out. Notice we can put the root of 3, or the exponent of 3, sorry, inside or outside of parentheses. I would write it down both ways because as we go on, sometimes it's going to be easier to think of it like this, sometimes it will be easier to think of it like this. This next one we have y to the negative 3.5 power. If we think of negative 3.5 as a fraction, it's negative 7/2. And we cannot leave a negative exponent in our answer, so how we change that positive, we just move it across this division bar. So if it's in the numerator and it's negative, we switch it to the denominator. If it's in the denominator and it's negative, we switch it to the numerator. So moving it across that division bar will change the sign of it. So we're going to move it to the denominator, and then we're going to simplify like up above. So then we have our 2 goes as our root, 7 goes as our exponent. We have 7y, so we can bring them out in groups of 2. So we have 1, 2, 3 pairs, so y to the 3rd power times the square root of y. Now we cannot leave that as our final answer. We can't leave a square root in the denominator. So we're going to multiply top and bottom by 1 more y, so we can have a pair here. If we multiply it by square root of y on bottom, we have to do that on top. So now we have another pair of y's, so we bring out another y, so we have y to the 4th in the denominator, then 1 times square root of y is just 1 square root of y. We can't simplify that any further, so that would be our final answer. This next one, we have square root of a to the 5th power, so then there's no root number, then it's just the square root, so that would be a to the 5/2 power, and we can just leave it like that. And this one, notice the exponent is on the outside, that's perfectly fine. We do it the exact same way. The exponent goes as our numerator, the root goes as our denominator, so we'd have b to the 3/5 power. This next one, again, it's a negative exponent. We can't leave it with a negative exponent, so we're going to change it positive to start with by moving it across that division bar. So then we have w to the 5/8 power. We're going to switch it to radical form, so the 8 goes as our root, the 5 goes as our exponent. We have 5 w's. We need 8 of them. We can't leave a radical in the denominator, so we need 3 more of them. So we're going to multiply by 3 more w's across the top and the bottom. Now we have 8 w's, so we can bring out a w. We have just 3 w's in the numerator, so we can't simplify that. So it would be the eighth root of 3 to the 3rd power divided by w. This next one, we have w to the 0.2 power. So we're going to switch that to a fraction. And if you're struggling, if you don't know what the fractions are, how you can do it using your calculator, if you just put in your decimal, so 0.2, click enter, and then go to math, FRAC stands for fraction, click enter, enter, and it'll give you the decimal as a fraction, so 1/5. So we had w to the 1/5 power. We switched that to our radical form. So we have the 5th root of w to the 1st power. Now this one, it doesn't matter if we have a radical left in the numerator, so then that would just be our final answer. The next section is combining radical expressions. So we have for our first problem, the 4th root of x to the 3rd power divided by the 8th root of x to the 2nd power. Notice the roots are different, so right from the start we can't go ahead and divide them. So what we're going to have to do is we're going to switch it to exponential form. So we would have x to the 3/4 power divided by x to the 2/8 power. The 2/8, we can reduce that to 1/4. And then from here, if we move the exponent across that division bar, it switches the sign. So notice this 1/4 is positive down here. So if we move it across that division bar, it would be negative up here. So we could go ahead and subtract those exponents. So then we would have nothing in the denominator any longer. So 3/4 minus 1/4, we get 2/4, which reduces to half. So we can leave our final answer as x to the 1/2 power, or you can rewrite it in radical form as the square root of x. This next one, we have the square root of 3 times the 4th root of 3. Notice the roots are different, so we cannot go ahead and multiply those, but we can switch them to our exponential form. So we have 3 to the 1/2 power times 3 to the 1/4 power. Notice the bases are the same, so we can go ahead and multiply those. When the bases are the same, we leave the base alone, we get 3, and then we add our exponents, 1/2 plus 1/4, and we get 3/4. So 3 to the 3/4 power would be our final answer. If you want to go ahead and put it in radical form, we'd have 3 to the 3rd power and then the 4th root of that. And then since we have 3 3's, we need 4 of them. We can't bring anything out, so it'd just be the 4th root of 27. Now we're going to simplify numbers with rational exponents. So for this one, we're going to do these problems 2 different ways. So the first method, we have 16 to the negative 2.5 power. So we're going to switch that to a fraction, 16 to the negative 5/2 power. We're going to change 16. Think of our factor trees. It would be 2 to the 4th power. And then from here, we have a power to a power, so we're going to multiply those. 4 times negative 5/2. So 4 times negative 5/2, think top times top, bottom times bottom. We get negative 20 divided by 2, which is negative 10. So 2 to the negative 10th power. We can't leave with a negative exponent, so we're going to have to move that across the division bar. So 1 divided by 2 to the 10th power, which is 1 divided by 1024. Now this other method that we have, we can work on it in using radicals. So we can't have a negative exponent, so we can move that across the division bar. So we'd have 1 divided by 16 to the 5/2 power. We can put 16 as our number underneath the radical, the denominator as our root, the numerator as our exponent. The square root of 16 is just 4, so we'd have 4 to the 5th power, which is then 1024, and then we just leave the 1 in the numerator. Again, that's when it comes in handy that 5 can go on the inside or the outside. And in this case, on the outside makes it a lot easier because we already know what the square root of 16 is. Alrighty, this next problem we have negative 32 to the 4/5 power. So again, we're going to keep continuing to do with both methods so you can see which method makes more sense for you. So negative 32, if we do our factor tree, we have 2 to the 5th power. Since it's negative, it's going to be negative 2 to the 5th power. And then we have a power to a power, so we're going to multiply those. Think of this 5 as a fraction, so top times top, bottom times bottom, we get 20 divided by 5, which reduces to 4. Negative 2 to the 4th power, we can either do that on our calculator doing our caret button, and we get 16, or we can just expand it out, negative 2 times negative 2 times negative 2 times negative 2, and get 16 that way also. Now the second method, we're going to go ahead and switch it to our radical form. So the negative 32 comes underneath, and then the denominator goes as our root, our numerator goes as our exponent. And then think of our factor tree for negative 32. We have 5 negative 2's, so we can bring out a negative 2, and then we take that to the 4th power because we haven't done the 4th power yet. So negative 2 to the 4th power, we get 16. Now this next one, we have 32 to the negative 3/5 power. 32 is 2 to the 5th power. And then we have to the negative 3/5 power, so power to power, we multiply those. So we have negative 15 over 5, which is negative 3. 2 to the negative 3rd power is We have a negative exponent, so move it to the denominator, 2 to the third power, so then 1 over our 8. The other option that we have, right from the start, we see we have a negative exponent. We can make that positive, so 1 over 32 to the positive 3/5 power. Switch it to radical form, so the 5th root of 32 to the third power. The 5th root of 32, notice we have 5 2, so we can bring in a 2, take that to the third power, so we'd have 1 over 8. The last type of problem we're going to go through in this section is writing expressions in simplest form. So the first problem, we have negative 8x times the square root of 2/3. Let me start all over. I think I butchered that. Negative 8x times the square root of xy to the 2/3 power. There we go. So for this problem, notice this is all in parentheses to the 2/3 power. So that means each of these are to the 2/3 power. So we're going to take and expand it out. Negative 8 to the 2/3 power, x is to the 2/3 power, and then the square root of xy is to the 2/3 power. Now instead of having a root and to the 2/3 power, I'm going to rewrite that as this square root of xy is just xy to the 1/2 power, because my root goes as my denominator and my exponent goes as my numerator. So then it's all in exponents. So then from here, negative 8, I'm going to rewrite that as negative 2 times negative 2 times negative 2, so negative 2 to the third power. And then over here, I have power to power, so I'm going to multiply those. Over here, I have power to power, so I'm going to multiply those. Then I'm going to start reducing these fractions. So 6 divided by 3 is just 2. 2, 6, I can reduce that to 1/3. Notice these are both to the 1/3 power, so I'm going to split that. X is to the 1/3 power, y is to the 1/3 power. Negative 2 to the second power is just 4. And then I can combine my x's. My bases are the same, so I'm going to add my exponents. 2/3 plus 1/3 I get is 3/3, or just 1. So I have 4 times x to the first power times y to the 1/3 power. I can leave it like this, or I could go ahead and put this back in radical form, so it'd be 4x to the cube root of y. So either of these answers would be fine. This next one, again, all of this is in parentheses, so that's all to the negative 1/3 power, so I'm going to expand it out. 8 is to the negative 1/3 power, x to the 15 is to the negative 1/3 power. So then 8, think of as 2 times 2 times 2, so we're going to rewrite that as 2 to the third power. I'll go ahead and show that method next. So for this, if we keep going this method, notice over here we have a power to a power, so we're going to multiply those, so we get x to the negative 5th power. Our exponents are negative, so we're going to move them to the denominator to make them positive. And then here we go. Now I have 8 is to the 1/3 power, so 8 is 2 times 2 times 2, so 2 to the third power. I have power to a power, so I multiply those. So 3 times 1/3, I get 1. So I have 2 to the first power times x to the 5th power. I can't simplify that, so then that is going to be my final answer. Alrighty, this last problem we're going to go through, we have 16y to the negative 8th power to the negative 3/4 power. So we're going to expand it out. 16 is in the negative 3/4 power. Y to the negative 8 is to the negative 3/4 power. And then from here, 16 is 2 to the 4th power. If we think of our factor tree, 2 times 2 times 2 times 2. And then we have power to a power, so we can multiply those. So think top times top, bottom times bottom, so we get negative 12 divided by 4, which is negative 3. Here, if we make that a fraction, negative 8 times negative 3 is positive 24 divided by 4 is positive 6. Here, the y to the 6th power, we're going to leave in the numerator. It's already to the positive exponent, but this we're going to have to move to the denominator because it's negative exponent. So now it is positive when we switch it to the denominator. And then 2 to the third power is just 8. So we have y to the 6th power divided by 8 as our final answer.